So in this problem, we would like to somehow play with step functions, or not step functions, sorry, with simple functions, what we call a simple function, okay, on the real lines. So we start first by looking at f, which is defined on an interval AB into R. We assume that it is continuous, okay, and what we want to do is, let me explain here on the graph. So we have AB, and what we want is to find the subdivision so we want to find that subdivision such that we can find a function that is phi, which is a simple function, which means it's constant on these intervals, which approximates f. In what sense does it approximate f? It means that sup of f of x minus phi of f of x is less than epsilon, where x is between a and b. So we call it the uniform approximation. Okay? So how do we do that? So first, note that since f is continuous on AB, it is uniformly continuous. Okay? So for every epsilon, there exists delta such that for any x and y in AB, such that x minus y is less than delta, we have f of x minus f of y, which is less than epsilon. So uniform convexity will help us a lot here. Okay? So what we do next, choose delta bar less than delta. And what we are going to do, we are going to subdivide the interval AB by using this delta bar. So we start by x0 to be equal to a, okay? And we pick, so this x1, which is a plus delta bar, okay? And xi is equal to a plus I delta bar. And b is going to be the last one. So we may have, so we pick the last one. So you pick here. So you may jump out, but you choose p instead of taking this one here, which is your xn plus 1. Okay, so once it exceeds, you take the last one being b. So what happens? So this way, we are able to find a subdivision, okay, such that from xi to xi plus 1, the difference is equal to delta bar, which is less than delta. Okay, so we have xi plus 1 minus xi is equal to delta bar, which is less than delta. Okay, and now you take phi defined on AB into R such that for every x in the interval xi plus 1 open, okay, we take phi of x to be equal to f of xi. Okay, so in this case, what we have a step function. Obviously, phi is a step function, or simple function. Sorry, simple function. Okay, and for any x in AB, okay, we know that there exists I such that x belongs to xi plus 1, And then we have absolute value of f of x minus phi of x is going to be f of x minus f of xi by definition of phi of x. And since xi minus x is less than delta bar, less than delta, this will be less than epsilon. So this is for every x in AB, and this will give you a uniform approximation as such.